So firstly, you know, it's all well and good to begin with some packed produce and then try to model or determine how it's going to perform post-harvest in export markets. But there's a lot of pre-harvest factors in the orchard which determine a lot of what happens after harvest. And this is an example. So this is the kind of variation you will find in stone fruit, in this case an early season nectarine, among trees, within trees, in fruit size and soluble solids concentration, which is basically sugars, or which represents sweetness. And the variability is measured with coefficient variation, and as you can see, it's quite high, and it does vary a bit from top of the tree to the bottom of the tree. So you're beginning with a very variable product, and even after the product is harvested and graded on a packing line by the grower, there's a lot of this variability remains. So we're dealing, as I said, we're not dealing with widgets, we're dealing with a biological product that's highly variable, and this causes all manner of problems later on. And I'll just put this up here, you know, in terms of the science behind what causes this variability in the orchard, well, there's a lot of factors. You know, there's carbohydrate availability of the fruit, which is impacted on by how much fruit is growing on the tree, or the crop load, fruit exposure to the sun, solar radiation, fruit development. One fruit's developing quicker than the other on the tree. How does that impact on post-harvest? And then there's things like even the fruit flesh anatomy and cell size distribution in the fruit. A lot of factors that impact on the post-harvest performance that we try to account for, but it's difficult, it's complex. And so you're always going to have, when you try to make a prediction in export markets about the quality of a batch of fruit, there's always going to be this uncertainty or confidence interval about the prediction. You can predict that fruit will get into export markets with a firmness of a certain amount, you know, 5 kilogram firmness, but there's always going to be an uncertainty because of this biological variation. And this is just showing, this one's the effect of, for example, the effect of the number of fruit on the tree, so crop load, so high, commercial and low, and position within the tree, top of the tree, bottom. And you see, depending on where the fruit's harvested, you can get quite a big difference in the fruit size, fruit mass, and soluble solids concentration. So this is the kind of variability we're actually dealing with at harvest, when we're harvesting our fruit. And another factor is exposure of the fruit to solar radiation or sunlight. Obviously, in this case, blush fruit is significantly, or is much higher, relatively higher in soluble solids than greener fruit. And there's also an effect of the position in the tree, again, demonstrating the kind of variation we have to deal with. Let's move on to harvest maturity and eating quality. We've got various technologies available to us to actually measure fruit quality, some destructive, some non-destructive, and some of the non-destructive methods are based on visible NIR. The two that we tend to use is index of absorbance, or the famous DA meter, which is that orange meter there, and Dario Stefanelli had a seminar on that quite a while back, quite a detailed seminar, so I'll touch on that, but I'm not going to go into too much detail. And then the other unit we have is a NIR meter, which measures sugars and dry matter in fruit. It provides a full absorbance spectrum, but it does require a calibration model to account for temperature variations, orchard variations, so it's a bit more complex to use and time consuming. The DA meter doesn't measure the whole absorbance spectrum, but it doesn't require calibration necessarily, so you can go in there and use it to measure maturity. And I'll talk about the DA meter now and not necessarily the Felix. So the DA meter measures this index of absorbance difference, and it's related to the time course of ethylene production during fruit ripening. And using this DA meter, we can classify fruit at harvest or during storage into different maturity classes. And basically these maturity classes are based on ethylene production of the fruit. So there's some examples for stone fruit, where as your index begins, 2 is very immature to 0, very ripe fruit. As it moves along that index, the level of ethylene being produced increases, and we can categorise the fruit into immature, pre-ripe, or onset, and ripe, or post-climacteric, if you like. So it's a really good tool. It's very consistent for pome fruit, apples and pears, and stone fruit, and it's very useful. And this is just showing that we can use this non-destructive tool to measure maturity, and it correlates quite well with sort of the more classical measurements of maturity, which is flesh firmness, and hue angle, which is basically skin colour, and there's some nice correlations there for Williams pears. So it can replace your more, in the case of firmness, the destructive measurements of fruit quality with the non-destructive. And this is also the type of correlation we get for another a new blush pear variety we're working on, Lanya. We've got flesh firmness on the left and the DA meter values on the right, and you see the curves follow pretty much the same pattern as fruit matures. So again, we can utilise a DA meter non-destructively in the orchard and post-harvest without destroying the fruit, and get a fairly good indicator of the physiological maturity. And you can also, if you take measurements early enough in the orchard, you may be able to predict your harvest window or the time of harvest using the DA meter, which is another advantage there, by measuring on the fruit on the tree and following the maturity. You can actually, obviously a linear relationship, you can actually predict when harvest should occur, and that's useful for growers in organising their harvesting and marketing. And Christine Frasina and Dario Stefanelli are involved in looking at the effects of fruit maturity and volatiles, basically the aroma and flavour, which impact on the aroma and flavour of fruit. And they've been doing some work looking at, as the fruit ripens, the change in the volatile profile. And we've got 2 volatiles here, acetaldehyde, which provides a pungent fruity aroma, which you probably, if you know it when you smell it. And terpene, which is a floral spicy aroma, and you can see sort of the increase in those 2 volatiles with increasing ripening. So they're doing a lot of work looking at that, because obviously these volatiles impact on aroma, which impact on consumer acceptance and enjoyment of the product.